So in the first part of this problem, we looked at this circuit with a C1 capacitor, C1, in series with two capacitors, C2 and C3, which are in parallel with each other, and we wanted to know the total capacitance. To figure that out, we had to first calculate the parallel capacitance of C2 and C3, and we did that by adding them up. 4 microfarads plus 6 microfarads is 10 microfarads. And then to get the total capacitance of the circuit, we had to calculate the series capacitance of C1 in series with the pair C2 and C3, or C parallel. And the equation for series capacitance is 1 over C series is equal to 1 over C1 plus 1 over the next one, which is CP, which we just evaluated above. And we got C series is 5 microfarads. And so then we can say how much charge is stored on the capacitors, right? And so Q total is equal to C series times the voltage. This is our formula, Q equals CV. Q equals CV for a capacitor. And I can just pretend that whole thing is one giant capacitor with a capacitance of C series. And so that's equal to 5 microfarads times 10 volts, or 50 microcoulombs, which is 5 times 10 to the minus 5th coulombs. That's the total charge stored on all the capacitors. And so that's how much charge is stored everywhere. But if you look at this circuit, since the positive plate of C1 is the only thing that's accessible to the battery, that much charge, Q tote, must all be on C1. And similarly, it's down here, it's divided among these two guys, C2 and C3. Because remember, positive charges are pulled off this capacitor and dumped onto to the other capacitor, to the other side. And so since the total has to be the same, it gets divided among C2 and C3, but on this side it's all on C1. And so I can say C1 carries charge Q1 is just equal to Q tote. And then I can figure out the voltage across capacitor 1. Remember, the voltage around my circuit has to be, on all these different components, has to add up to 10 volts if I take any particular path through the circuit. So if I go across this guy and then across C2 and back to here, I should get the same 10 volt drop I get if I went from here to here. And so if I figure out the voltage V1, this will tell me that the voltage that's across capacitor C1, I've just rearranged my formula Q equals CV to solve for V, and so this gives me 50 microcoulombs over 10 microfarads, because C1 was 10 microfarads. And if I evaluate this, I get 5 volts. And so what this says is, of the 10 volts from the battery, there's a 5 volt drop here, which means there must also be a 5 volt drop across these two guys. So this voltage drop must be 5 volts, because we just determined that this voltage drop, V1, is 5 volts. Okay, so now we can figure out the charges on capacitors C2 and C3.